Spring AI looks easy to set up. It is not. The default auto configuration will burn you the moment real traffic hits your production service. Start with the Spring AI bill of materials in your Maven or Gradle build. Add the bomb block before any Spring AI dependency declarations. Without it, Spring Boot's dependency management and Spring AI's transitive dependencies will conflict. The failure is silent, your bean wiring looks fine, your tests pass. Then at runtime, you get a class not found error from a library you never touched directly. Notice how the bomb block sits inside the dependency management section. That placement is what tells Maven to apply Spring AI's version constraints across your entire project. The Spring ABOM artifact is the single source of truth for every transitive Spring AI version. One entry here prevents a whole class of silent version conflicts downstream. Now define your AI client bean yourself. Do not trust auto configuration to wire it correctly for your environment. Create a configuration class, annotate it with @configuration, and declare an @bean method that returns a chat client. You control the constructor arguments, you control the life cycle. Autoconfig is a shortcut that skips those decisions for you and makes the wrong ones. Your API key goes in an environment variable, not in application.properties, not in application.yaml. An environment variable, name it something like open AI API key, inject it with @value, and pass it into the client constructor. If that key ever lands in a Git commit, rotate it immediately, no exceptions. Configure the model parameters explicitly inside your bean definition. Set the model name as a string. Set temperature. A value between 0 and 1 controls creativity versus determinism. Set max tokens to cap your cost per call. Leaving any of these unset means the framework substitutes its own defaults. Those defaults were chosen for demos, not production workloads. Look at how the options object is built in line using the builder pattern. Model name, temperature, and max tokens are all explicit. Nothing is left to framework defaults. The API key flows in from the injected environment variable, never from a property file. This is the configuration shape your production environment actually needs. Wrap every AI call in a retry template. Large language model API endpoints enforce rate limits. Under moderate traffic, you will hit them. Configure exponential backoff. Start at 1 second, double on each retry, cap at 30 seconds, and stop after 5 attempts. Spring Retry gives you this in about 10 lines of configuration. Without it, a single rate limit spike cascades into a wall of errors for your users. Turn on request and response logging, but only in your development profile. Use Spring profiles to gate the logging bean. In development, full prompt logging is invaluable for debugging. In production, it is a liability. Your log aggregator will store every user prompt, every model response, every piece of sensitive context your users shared. That is a data breach waiting for an audit to find it. Here is the pitfall that catches everyone. If you use streaming responses from the model, the kind that push tokens to the client as they generate, standard Spring MVC will not handle it. The servlet model blocks. It waits for the full response before sending anything. You must switch to Spring Web Flux, or you must configure a server sent events endpoint explicitly. Decide this before you write a single controller. Changing it later means refactoring your entire request pipeline. See how the controller returns a flux of server sent event rather than a plain string. The stream method on the chat client emits tokens as they arrive, and the map step wraps each chunk into an SSE frame the browser can consume incrementally. There is no blocking here where the Webflux thread is free the entire time the model is generating. Subscribe. Next video, Spring AI memory and conversation context.